Once, Frank Tiger said, "For those who keep trying, failure is temporary." Good morning, students. Let us start a new chapter, continuity. A function fx is said to be continuous if we can draw a curve of fx on a plain paper without lifting the pen. Or mathematically, a function fx is said to be continuous at x equal to a. At x equal to a, if the left hand limit LHL equal to right-handed limit RHL equal to value of a function at that point, or limit x tends to a minus fx is same as limit x tends to a plus fx is equal to f of a. If LHL equal to RHL equal to f of a, we can say that that function is continuous at x equal to a, or limit h tends to 0, f of a minus h equal to limit h tends to 0, a plus h equal to f of a. Otherwise, it is discontinuous at x equal to a. Then, write down the next one. Continuity at a point. Continuity at a point. Write one by one. Continuity at a point. A function, first all of you write these notes. A function f is said to be continuous at x equal to a if limit x tends to a fx exists. Fx exists and limit x tends to a f of x equal to f of a. In other words, if, we repeat the same point. If limit x tends to a minus fx equal to limit x tends to a plus f of x equal to f of a, then we can say that the function fx is continuous at x equal to a. Then, how can you define discontinuity? What's the meaning discontinuity? Write the heading discontinuity. If the function f is not continuous at x equal to a, if the function fx is not continuous at x equal to a, then f is said to be discontinuous at x equal to a. That means 3 cases are there. Write one by one. Here, discontinuity. That means simple definition is the fx is not continuous. At x equal to a, then it is known as discontinuous. There are three types of discontinuity. There are three types of discontinuity, right? First one is removable discontinuity. Right. Limit x tends to a minus fx equal to limit x tends to a plus fx, but that not equal to f of a. The LHL and RHL limits are equal, but the value of the function at a equal not equal. Then we can say that is discontinuous or removable discontinuity. Here, we can remove it by redefining the function. We can remove the discontinuity by redefining the function. Then, discontinuity of first kind. Then B, right, discontinuity of first kind. That means limit x tends to a minus fx not equal to limit x tends to a plus fx. The LHL value not equal to RHL value. Then that function is discontinuous. That is of first kind. Then third one is C is discontinuity of second kind. Discontinuity of second kind. If at least one of the limits, means limit x tends to a minus fx or limit x tends to a plus fx does not exist at x equal to a, does not exist at x equal to a, then f has discontinuity of second kind. Then next write the very important note. Write the note continuous functions. Continuous functions. Write one by one. A constant function is everywhere continuous. Write one by one. A constant function is everywhere continuous. A constant function. Second one is a polynomial function. A polynomial function is everywhere continuous. X cube plus 3x square plus 5x plus 7. That polynomial function is everywhere continuous. Then the third one is a rational function. A rational function is continuous in its domain. A rational function is continuous in its domain. Fourth one, logarithmic function is continuous. Logarithmic function is continuous on the open interval 0 infinity. The open interval 0 to infinity. Then fifth one says exponential function. Exponential function is everywhere continuous. The exponential function is everywhere continuous. Then the sixth one is the modulus function. The modulus function is everywhere continuous. Modulus function is everywhere continuous. And the seventh one says trigonometric functions are continuous in their domains. Trigonometrical functions are continuous in their domain. Trigonometrical functions. Once again, a constant function, a polynomial function, a rational function, a logarithmic function, an exponential function, a modulus function, and a trigonometrical functions. These are always continuous functions. Then write the second very important note. If f and g are, if f and g are any two continuous functions, then 1. F plus g is continuous, 2. F minus g is continuous, and third, f into g is continuous, and the fourth operation, f by g, where g not equal to 0, is also continuous function. If f and g are continuous functions, then f plus g is continuous, f minus g is continuous, f dot g is continuous, and f by g is also continuous. Okay, then write this limit property one by one. Write limit x tends to 0, sin x by x equal to 1. All of you know this formula. And limit x tends to 0, tan x by x is also 1. Then the next, the third one, limit x tends to 0, e raised to x minus 1 by x equal to 1. Then the fourth one, limit x tends to 0, log 1 plus x by x is also 1. Then the next formula, limit x tends to a. You already studied these limits in the 11th standard, isn't it? Limit x tends to a, x raised to n minus a raised to n by x minus a equal to n a raised to n minus 1. And the last one, limit x tends to 0, a raised to x minus 1 by x is log a. Log a. Now, first all of you study these properties. Understand? Now we can do problems one by one. Very simple chapter. Write one by one. Prove that fx equal to 5x minus 3 is continuous. Continuous at x equal to 0. First question. Second, at x equal to minus 3. Then the third one, x equal to 5. First, all of you copy the question. What is fx given? Fx equal to 5x minus 3. Our aim is to show that this function is continuous at x equal to, right, at x equal to 0. Then, limit x tends to 0. F of x equal to, how can you find limit x tends to 0 fx? Yes, in the place of x we substitute 0. 5 into 0 minus 3. 0 minus 3 is minus 3. Then direct you have to find what is F0. F0 means 5 into 0 minus 3. That is also minus 3. Therefore, we can say that, right, limit x tends to 0, fx is equal to limit, not limit, f of 0. Limit x tends to 0, fx is the value minus 3. Direct f0 is also minus 3. Therefore, below write limit x tends to 0, fx equal to f0. Therefore, right, therefore, fx is continuous at x equal to 0. At x equal to 0. That's the first property. Limit x tends to a, f of x is equal to f of a. We can say that that function is continuous. What's the second question? 3 different questions. At x equal to minus 3. At x equal to minus 3. Right. Limit x tends to minus 3, fx equal to, limit x tends to minus 3, 5x minus 3. Copy the question also. X tends to minus 3, 5x minus 3 means in the place of x substitute minus 3. 5 into minus 3, minus 3. That is minus 15 minus 3. What is the final answer? Minus 8. Very good. Minus 8. Then you have to find f of minus 3 directly. What is f of minus 3? The function is 5x minus 3. 5 into minus 3 minus 3. That is minus 15 minus 3. That is also minus 18. But here the last sentence is very important. Limit x tends to minus 3, fx is equal to f of minus 3. Therefore, not to forget that, copy that sentence. Fx is continuous at x equal to minus 3. Fx is continuous at x equal to minus 3. Okay. The same function, one more question. What is that? To show that fx is continuous at x equal to 5. At x equal to 5. Can you do by yourself? Try. Limit x tends to 5 plus f of x. That is, limit x tends to 5 plus f of x means, yes, 5x minus 3. What's the answer? 5 into 5 minus 3. These steps are important. Otherwise, it looks all same. Understand? 5 into 5 minus 3 means 25 minus 3. What is the final answer? Yes, 22. Then can you say what is f of 5? F of 5 means direct substitution, 5x minus 3. 5 into 5 minus 3, that is 25 minus 3 is 22. Therefore, what is the conclusion step? Limit x tends to 5, f of x equal to f of 5. Therefore, fx is continuous at x equal to 5. Okay, students? Write the next question. Write the next question. Examine the continuity of the function. Examine the continuity of the function. Fx is equal to 2x square minus 1 at x equal to 3. At x equal to 3. Start. Yes, limit x tends to 3. Limit x tends to 3, fx. That is equal to limit x tends to 3. 2x square minus 1 is the function. Then substitute 2 into 3 square minus 1. 9 into 2, 18. 18 minus 1 is 17. Then also all of you find f of 3 directly. What is f of 3? 2 into 3 square minus 1. 9 into 2, 18 minus 1, that is 17. Then what is the last line? Limit x tends to 3, f of x equal to f of 3 equal to, actually here the answer is 17. Therefore, fx is continuous at x equal to 3. At x equal to 3. Okay. Then write one next question. All of you copy the next question. Show that the function fx equal to x square when x not equal to 1 and equal to 2. This fx takes the value 2 when x equal to 1 is discontinuous at x equal to 1. Is discontinuous at x equal to 1. Okay, we can start. Right. Limit x tends to, here x equal to 1 means 1 f of x. F of x means x square, isn't it? That is, limit x tends to 1 x square. What is the answer? 1 square. Can you say what is 1 square? Yes, 1. We apply limit. Then what is the next part? We find the value of the function at x equal to 1. All of you look at the board. At x equal to 1, the function takes the value 2. Therefore, f of 1 is equal to 2. Then below, limit x tends to 1 fx not equal to f of 1. Students, you understand this? Limit x tends to 1 fx not equal to f of 1. Two different values. Therefore, the function is not continuous. The function is not continuous means, yes, discontinuous at, right. The function is discontinuous at x equal to 1. Understand what is the meaning of continuous and discontinuous? Understand? So, study that basic part. Then, we can do more problems in the next class. Meet again. God bless you.